Okay, so today we're going to take a look at the first 6 problems from the SAT Practice Test 9 calculator section. So let's start with number 1. Remember, you're allowed to use your calculator for these problems, but I think for these 6 problems in particular, you're probably not going to need to use it very much, if at all. So let's start with number 1. What value of x satisfies the equation 3x plus 3 equals 27? So to solve this problem, you pretty much want to get your final solution to look something like this. X equals a random number, whatever that number is. And it's our job to solve for this number. So to do that, we need to make this equation look like this equation. And we just need to do that by using algebra to simplify this equation. So we start off by subtracting 3 from both sides to get rid of this plus 3. And so that'll give us 3x equals 27 minus 3, which is equal to 24. And from there, we need to get rid of this 3 in front of the x, which we can do by dividing both sides by 3. So your final answer will be x equals 24 divided by 3, which is equal to 8. And so your final answer for this question will be B, because that's 8. So that's number 1. Let's move on to number 2. 2 units of length used in ancient Egypt were cubits and palms, where 1 cubit is equivalent to 7 palms. The Great Sphinx statue in Giza is approximately 140 cubits long. Which of the following best approximates the length in palms of the Great Sphinx statue? So this question is basically asking us to convert 140 cubits into palms using the conversion factor 1 cubit is equivalent to 7 palms. And to do that, we can set up a ratio. So 1 cubit over 7 palms, because that's the conversion factor that's given to us in this question, is equal to 140 cubits over x amount of palms. And we need to solve for x. And so to solve for this x, we can just do cross multiplication. So this will turn into x equals 140 times 7. And so you would be tempted to plug this into a calculator to solve for the exact value of x, and that's normally what we would do. But in this case, if you look at these answer choices, we won't need to, because none of these answer choices except for D look anything close like what 140 times 7 would look like. 140 times 7 is not going to magically become less than 140, so you can immediately cancel out these two. And then it's not going to be equal to 140 either, because 7 is obviously you're adding 140 by itself 7 times. So it's obviously going to be much greater than 140. And so that only leaves D, 980, as your final answer. Normally, we wouldn't use process of elimination, and we would actually plug this into a calculator to be safe. But in this case, it's pretty obvious that it's going to be D, because none of these other answer choices are anywhere near, not near what 140 times 7 would be. So that's number 2. So number 3, if 2n over 5 equals 10, what is the value of 2n minus 1? So in this, we can see that 2n is a constant in both equations, as seen here. And so what we can do is simplify this equation to find what 2n equals and plug that into this equation. So to do that, we just multiply both sides of this equation by 5. So 2n equals 10 times 5, and that's obviously 50. And from here, we actually don't need to solve for what n equals, because we know n equals 25 because divide by 2. But we don't need this information in the question, because 2n is a constant in both equations. So we can directly plug 50 in for 2n in this equation to solve for what 2n minus 1 is. And that's what we're going to do. So we don't need to solve. We don't need this step at all. This is a waste of time. Sure, it'll take like 2 seconds to solve this, but that 2 seconds could help you later down the road. So this is just a time management strategy. If you don't need to do it, just don't waste your time doing it. And so to solve for the final answer, it's going to be 50 minus 1, which is obviously 49. And we plug in 50 because that's what we got from simplifying the first equation. So 2n equals 50, plug 50 in for 2n, and 50 minus 1 equals 49, which is our final answer. So that's number 3. For number 4, which of the following values of x is not a solution to the equation above? And the equation above is the square root of x squared equals x. Now we know from our properties of square roots that the square root of any number So like if we say the square root of z, it cannot be less than 0. It's not possible for it to be less than 0, because if you a square root of something, the inside of a square root cannot be negative, basically. And because of that, the outside cannot be negative either, because if you multiply a negative times a negative, that's going to give you a positive. And similarly, if you multiply a positive by a positive, that's going to give you a negative, or that's going to give you a positive, rather. And so because of this, there's no possible way for the inside of a square root to be equal to a negative number, because the inside of a square root is pretty much a number squared, right? Because you can't take a square root of like a base number. You have to, the inside of a square root is always going to be something else squared. And so because of that, that something else has to be like either negative or positive. And because of that, if you square something, it's always going to be positive. And so due to that logic, you can't have the inside of a square root be equal to anything negative. And so we know that A is immediately the right answer. We can check this, like test this theory, I guess, by plugging -4 into this equation to see if we'll get the accurate solution. So let's just quickly do that. The square root of -4 squared equals -4. Let's check if this is correct. So -4 squared equals 16. So we can rewrite this as the square root of 16 equals -4. But the square root of 16 is not -4. The square root of 16 is a +4. And so because of this, +4 is not equal to -4, obviously. And so because of this, we know that -4 is the correct answer to this, because it's not going to give us any possible solutions. So that's number 4. This one requires you to know a bit more about like the nature of a square root function. And so number 5 and number 6 actually refer to this following information. So let's quickly take a look at this. In an experiment, a heated cup of coffee is removed from a heat source, and the cup of coffee is then left in a room that is kept at constant temperature. The graph above shows the temperature in degrees Fahrenheit of the coffee immediately after being removed from the heat source and at 10-minute intervals thereafter. So this graph is a temperature over time graph. So the y-axis is temperature in degrees Fahrenheit, and the x-axis is the time since the cup was removed from the heat source. So this is going to be very important for when we solve these two questions. So number 5, of the following choices, which best approximates the temperature in degrees Fahrenheit of the coffee when it is first removed from the heat source? The phrase first removed implies that we're looking for the initial temperature, like the temperature of the coffee cup right after it was removed from the heat source. And so that will be at time t equals 0, because it's right after it's been removed. And so we just need to look at the point that is at time t equals 0, which is up here. And this point is on the y-axis, it's close to 200. So looking at our choices, D makes the most sense, because it's pretty close to 200, but it's not quite there. Number 6, during which of the following 10-minute intervals does the temperature of the coffee decrease at the greatest average rate? This one is basically asking us to find during which of these intervals is the slope the smallest. So if you look at this graph, you'll see that the farther it gets to the right, the farther along it goes, the less it changes, like the less of a change there is between the 2 points. So if we look at, for example, this last point, the difference between these last 2 points in this interval is very small. These points are practically on the same level, right? There's not much of a drop. However, if you look at this first interval, the drop from this point to this point is massive. It's like almost 20 degrees Fahrenheit. So you can tell that the further right it goes, the less it drops. You can tell that just by looking at this graph. And so we automatically know that the answer is going to be D, because that's the farthest to the right. This interval is farthest to the right when compared to any of these others. And so that's going to be a right answer. We can check that by just looking at the graph. Between 0 and 10 minutes, that's almost like a 20 degree Fahrenheit gap. So that's obviously not going to be the right answer. Between 30 and 40 minutes, that's this one here. It's roughly a 10 degrees Fahrenheit drop, more or less, which is a relatively large amount, but it might be an answer. It's a possible solution. Between 50 and 60 minutes, that is this one. Again, it's a little bit less than 30 and 40, but it's still not like, it's still a reasonable drop. It's again almost 10 degrees Fahrenheit of a drop. But then between 90 and 100 minutes, that is here. It's a drop, but it's like it's barely a drop. Hardly tell the um you can hardly tell the difference between these 2 points in terms of elevation. So you can check that 90 and 100 minutes is going to be the smallest drop in terms of, we're looking at a drop for the y-axis because drops in terms of temperature degrees Fahrenheit. So you can either like guess and not really get, you can either use process of elimination and just look at each of the intervals given to us, or you can just examine the nature of this graph and see that the further along to the right you get, the less of a drop there's going to be. And so whichever one of these intervals is furthest to the right is going to be your answer because there's the least amount of decrease in terms of temperature.